All right, part 2. So this fact leads to a P-series test on page 611. If you remember back from section 8.8, page 578, we had this integral from 1 to infinity 1 over x to the p. The result we got was that it was 1 over p minus 1 when the p was greater than 1, so that converged. But if the p was less than or equal to 1, you got an infinite result and it diverged. So this leads to what's called a p-series. We're going to add up 1 over n to the p, just like you're integrating 1 over x to the p. And you can see individual terms work out like that. You're just putting in the numbers for n, not the p. So if p equals 1, they give it a new name. It's called harmonic. So if p is 1, of course you don't have to show the 1 exponent, but a sum of 1 over n, let's do 1 plus a half plus a third plus a fourth. You're just adding fractions with whole numbers on the bottom. So by 8.8 and by 9.3 here, this sum will converge if the p is greater than 1. Because if you remember back from 8.8, you got it converging when the p was greater than 1 on that integral. It diverges p less than or equal to 1. So this is a very important result, that if you can recognize a series is harmonic, a harmonic series diverges. Harmonic means it has linear terms on the bottom. So the straight harmonic is a straight 1 over n. Again, adding these fractions up to infinity, and it will diverge, since it is a p-series with p equal 1. Now, you can make all kinds of little variations on this and it's still harmonic. You can add or subtract a number in the bottom. You can put a coefficient on the end, and this result that it will diverge still holds. I'll give you some examples on the next sheet. Here's some examples. You can put a 1 over 2n, added 3 on bottom, 1 over n plus 3. Put a coefficient, subtract 4. Coefficient, add 5. All of these are harmonic. What makes them harmonic is the first power of n. If you write out the terms will just be shifted, but they still will ultimately be those they will still be those positive fractions. When you add them up, you'll add to infinity. These are all harmonic and they all diverge. The only important point is the power on the n is 1. Linear terms on bottom are all harmonic and all diverge. But if you change that power, your conclusion changes. So for example, a 1 over square root n makes a sum of 1 over n to a half. That's a half power. P-series, the p is a half. That half is less than 1. That diverges. If you make a 1 over n squared, that's a p-series. The p is greater than 1. You converge. Part 2 is over. Come back for part 3.